Hi, my name is Courtney.
I'm Sam.
I'm Shubham.
I'm Sunit.
And I'm Ryan.
And we are the Baraga Lakeside Inn team. We worked at a hotel located in Baraga, Michigan to fix a noise control problem they had in their dining area. When we were approached about this project, we decided to talk to our sponsor, Gary Lubinsky, the owner of the Baraga Lakeside Inn, to talk about the issues that he was facing in the dining area.
I'm Gary Lubinsky, and I contacted Michigan Tech to do a sound analysis on our bar and our elevator room, and we had a bar that was almost like a closet, and we wanted to open it up so that the patrons in the bar could see the water. And so we took some windows out and we made we took the wall out below the windows and had a fairly good opening. But I noticed right away, sitting in the restaurant, that the patrons in the bar were extremely loud. It almost like the bar was amplifying the sound coming through that window. And then we also moved the door and took the door off to access from the restaurant to the bar.
So, after hearing Gary's description of the problem, we decided to investigate the bar area ourselves and figure out what the problem was. As previously discussed, the two areas of interest for our project were the bar and the dining room. The dining room is about 3 times larger than the bar room. The wall between the two rooms had a large window to allow the bar some natural light and a view of the bay, and a door was added leading directly from the dining room to the bar to encourage traffic between the two rooms.
Before taking any acoustic measure of the bar and the restaurant, our team brainstormed what the problem might be. We thought there would be 2 primary concerns which we should be dealing here. One would be the absorption of the bar and the receiving room, that is the dining room, or the transmission loss. So the idea is, if the absorption of the room is not high enough, then you have enough sound that it can escape out. If the transmission loss of the partition that joins the bar and the restaurant is low, then again sound can easily escape through it. In keeping with this thought process, our team went down there and started taking the measurements for absorption and transmission loss. And yes, we know it's close to May and we still have snow. Welcome to Houghton!
From here on, we'll take the bar area as a source room and the dining area as the receiver room. In order to calculate the absorption of the 2 rooms, we first measured the T60 time in the 2 rooms. The T60 time is the time taken by the sound pressure level to decrease by 60 dBs. We also took the actual measurements in order to calculate the surface area and the volume of the 2 rooms. While recording the data, we also made sure that there were no one inside the room, as it will increase the absorption of the room.
Transmission loss of the wall was found by recording sound pressure levels in the source room and the receiver room with a known source in the bar room. The speaker was placed on top of the bar to simulate where people actually would be in the bar. And the source was placed in 3 different corners of the room to allow for a diffuse field assumption. Diffuse field allows for approximately even sound pressure distribution throughout the room. To process the data and assist in calculation of absorption and transmission loss, a magical code was written.
So while we were measuring the data, we didn't handle the sound level meter very well, and we didn't mount it on the tripod very well. So that brings us to the concessions. Oh wait, confession time. Because we didn't handle it, we didn't do it very well, we stood up to the class and told them that these were the mistakes that we were making so that they don't do it. Now back to the signal analysis part of it. Once we had all the data, we needed to make sure that all of that data makes sense. Thinking is not optional. So we went back and checked what we were measuring, whether it was the right thing or not, before we averaged it to get the absorption of the bar and the restaurant. Once we had that, we just measured sound pressure level in both the rooms to figure out the existing transmission loss. We now needed some reference values as to what would be the value of sound pressure level in the bar in existing condition. So we went bar hopping in Houghton. We went to different bars, took our sound level meter with us and measured the sound pressure levels on a busy Friday night. Turns out KBC is the loudest, as we expected. But we used this value as the sound pressure level in the bar and then figured out what should be the sound pressure, and for reference values of the restaurant, we just took its background. So in a way, we were trying to design a system when the bar is as loud as KBC and the sound pressure level in the restaurant doesn't even change.
After all the data crunching, we obtained the desired transmission loss and compared it with existing values, and we noticed a room for improvement. Therefore, we decided to increase the transmission loss of the partition. We had a design constraint that the owner wanted a French door which limited our options for the window. We considered two options, single panel and a double panel design. We considered only those materials which are readily available in the market and hence would be cheaper than the custom designs. Single panels are effective only till a certain frequency known as coincidence frequency, which is a function of material properties of the panel. Double panels not only have better transmission loss for same thickness but also get rid of this limitation. Based on these design options, we tried out different materials and with different thicknesses, and our final results are represented such that the improvement in the SPL level can be clearly observed with different options.
In conclusion, we recommend polymethyl methacrylate for window material in the configuration of 2 3/8 inches or 2 1/8 inch thick panels with a 3/4 inch air gap in between.
The overall sound level in the receiver room could be reduced by approximately 29 dBA, bringing it down to 47 dBA, which is close to the existing overall background levels in the room.
We think our recommendation can help the owner to solve the noise control problem.
To conclude, we'd like to thank Dr. Andrew Barnard for his guidance through our project.
We would also like to thank Gary Lipinski, the owner of the hotel, for allowing us to come and help him with this problem and for the free pizza.
We would also like to thank William Larson for his constant support throughout the project.
When we figured out, or what should I say, when we...
You were so natural, what happened?
I lost it! Okay, so I'll say...
Does my hair look? Is my hair good?
Yep.
It's fantastic. Alright, so what am I discussing here? Like,
Before taking any acoustic measurements of the bar and the restaurant, Baraga Lakeside Inn. Introduction. Scene 1. Take 2. Action.
okay, I just gotta say this one thing. So we didn't calculate T60 times we measured.
I started bad.
Yes.
Or 2 1/8 inch thick panels with a